Hello everyone. So now we are going to work on this problem where it's going to be a nice example of how to use exponentiation to our advantage. So we would like to note that 12 is congruent to 1 mod 11 and 21 is congruent to negative 1 mod 11. Part A asks us to find a remainder when 12 to the 100 is divided by 11, and part B asks us to find a remainder when 21 to the 100th power is divided by 11. So, let's get started. Part A. And let's also establish what we know. The thing we had just proven was that a1 to the nth power, well, I should say if a1 is congruent to a2 mod m, then we have that a1 to the nth power is congruent to a2 to the nth power mod m. And vice versa. So, well, part A states to find the remainder when 12 to the 100th is divided by 11. Well, 12 to the 100, that's a large number, perhaps too great for the calculator. And we want to find what that is mod 11. Well, according to the exponentiation property, that is just what that really just becomes is let's say, for example, this is congruent to x to some nth power mod 11. But what this also implies is that what this gets us is that, well, 12 mod 11 is congruent to, well, 12 mod 11 we know is 1 mod 11. So that means my x is a 1. Oh, I shouldn't have even put n here. I should have put to the 100th power. Sorry. Make it a little bit more clear. But yeah, this establishes that my x is 1. And 1 to the 100th power is just congruent to 1. Mod 11, of course. But still just 1. Okay. Now, I'm not going to write it out in as much detail for part B, because I think the basic gist has gotten across to us. We don't need to really write it out in the manner in which I did. But it wants us to find the remainder when 21 to the 100th power is divided by 11. So 21 to the 100th power is congruent to, well, I know 21 is congruent to negative 1 mod 11. So it's congruent to negative 1 to the 100th power mod 11. And that is congruent to, well, anything raised to an even numbered exponent becomes positive. So in this case, it's going to become a positive 1, then mod 11. So 21 to the 100th power is congruent to positive 1 mod 11. Finally, part C is 21 to the 100th power minus 12 to the 100th power. Is that a multiple of 11? So I want to find out if this mod 11 is 0. Because if the remainder is 0, it must be a multiple. Well, we know that this is congruent to 21 to the 100th power mod 11 is just 1. Then we have minus 12 to the 100th power. I'll even write parentheses about what we're substituting. 12 to the 100th power is also positive 1. But that reduces to 1 minus 1. Be careful with those subtraction signs. That's why I put the parentheses. And, well, 1 minus 1 is indeed 0. Mod 11. So, yes is our answer. Yes. Multiple of 11. Because it has a remainder of 0 after that subtraction. So we had to combine the exponentiation property with our subtraction property as well. But we could see how it makes these values that are almost too large to fit in a calculator into such simplistic numbers that it's not even worth worrying about.